Okay, so I'm just going to go over a very high-level review of Quicksort and then a small concrete example to demonstrate how it works. So we're going to define Quicksort, QS of A, some array of sortable objects, integers, strings, whatever. First step is just the base case. If the array is length 1, then it's trivially sorted, right? So that's going to be our base case. So n 1, then we just return A. The next step for Quicksort, at the very beginning for a general case, we have to pick some pivot element P. So select the pivot P. I won't go over how that selection is done. Then the next step after that is, after we have our pivot, we want to partition all the elements of A, except for P itself, into two subarrays based on whether the elements are going to end up to the left of P or to the right of P in the final sorted array. So partition A without P into, and we'll call it L and R for left and right. And it depends on whether they're less than or greater than P, right? So I'll just write less than P versus greater than P. After we've partitioned A into two parts, we have two smaller subarrays. So since this is a recursive algorithm, next step is pretty straightforward. We want to recurse. So we'll do Quicksort on the left subarray and on the right. And finally, again, pretty straightforward for a recursive algorithm. Now that we've recursed, we have these two parts, and we just combine them together, and then P goes right in the middle, right? Okay, so that's a very high-level review of Quicksort. I'll do a small example. We'll just look at the integers 1 through 7. They're given to us in some random order, right? Let's say 6, 2, 1, 4, 5, 3, 7. I'll just always pick the actual middle element as a pivot just to make this go faster, just for the example. So in this case, that's 4. It's going to be our pivot. It's going to be in the middle. And we're going to look at all these elements and see which ones are less than 4 and which ones are greater than 4, right? So the ones that are less are 2, 1, 3, and they'll go on the left of 4, right? So 2 and 3. Then the elements that are greater than 4, 6, 5, 7, right? So they go to the right, 6, 5, 7. Now we're going to recurse on left subarray and the right subarray. So we're going to pick pivots. So here that's going to be 2. And over here that's going to be 6. Then we're going to look at these, in these subarrays, we're going to look at which ones are supposed to be to the left of the pivot, which one's supposed to be the right. So here, 1 is less than 2, and then 3 is greater than 2, right? On this side, 5 is less than 6, and 7 is greater. Now our subarrays are all length 1, right? So now we're in our base case. There's nothing left to do because these are each individual elements by themselves, and we don't have to do anything to sort them, right? So now we can start recombining our results. So it's going back up, basically. And so we're looking at, this is the left subarray, this is the right subarray, and the pivot goes right in the middle, right? So 1 and 2, 3. Same thing on this side. We have the left and the right subarrays, and the pivot goes right in the middle, so 5, 6, 7. So now we have these two subarrays here, the sorted, quick sorted versions of these. And now we just recombine again, right? One more level up, and the pivot here was 4, right? So 1, 2, 3, 4, 5, 6, 7. That's a quick example of quick sort.